Hello everyone. In this session, we're going to solve this quantum mechanics problem. So let me first state what's in the question. So we are given an asymmetric double wheel potential, which is pictured here, and which has a Hamiltonian that looks like this. Now T, the operator T, this thing describes the tunneling between the two wheels. And in the absence of, so this describes tunneling. And in the absence of it, where t is 0, we have the Hamiltonian to be h naught, and h naught has eigenstates psi l, which has associated eigenvalue, energy eigenvalue el. Similarly, the state psi r has eigenvalue er. When the tunneling is present and when it acts on the state psi l, we have the following output, delta times psi r, which basically switches the states, and if it acts on psi r, we have psi l. In both the cases, notice the factors are equal, and they belong to the real number and real positive number, right? So with that in mind, let's solve the first problem. So in question A, we are told to find the eigenstate psi 1 and psi 2 of the system as a linear combination of psi l and psi r. Right. So and we are also told to find the associated energy eigenvalues and the difference between the two eigenvalues. So let's assume the eigen states of the general Hamiltonian H to be psi. It gives us energy, let's say E tilde. Assume psi is written as a linear combination of psi l and psi r. The linear combination is thus. Right. So next, what you're gonna do is we're gonna act on psi with Hamiltonian, which should give us this thing. Dot on h naught t acting on this thing. Now h naught, if h naught acts on psi l, we know that it gives us el times psi l, right? So this thing acting on those two things should give us and then t should act on this linear combination, and that should give us till it reverses the state. So the first term gives us this, and the second term should similarly give us this thing. And to the right, we have, if I write it down explicitly in terms of the linear combination, then this thing here. Now what we're gonna do is we're gonna take all the terms together, This is the coefficient of psi L, and similarly we will have the coefficient of psi R to be this thing. Now the linear combination of psi L and psi R is 0, so we can what it means is the coefficients must be 0, so that implies this thing is 0 and this thing is 0. So if we find the value of E tilde from here, we'd see this comes up to be from here we have and if we equate those two, we have this thing, and the cross multiplication now notice from this equation we can find C2 in terms of C1 or the other way around. So this is a quadratic equation in C2 where we can take C1 to be constant, so let's do that. So C2 and so from this thing we have C2 to be and let's wait for a bit. So if we go to the question, you can see they are telling us to use this thing EL minus ER to be epsilon, right? So we use that shorthand, then we are and take C1 common from here and CM common. So we have epsilon here, so minus epsilon plus minus root over epsilon, sorry, epsilon square plus 4 delta square divided by 2 delta. Right, so we can find out the value of C1 and C2 from using this equation, but for that we'd have to use another condition, that is the condition of normalization. Namely, we have written the eigenstate as a linear combination of the states psi L and psi R. Now this thing has to be normalized, so that would mean C1 mod square C2 mod square is 1. So let's use that. So the first one remains untouched, but we know from this equation that C2 written in terms of C1 looks like this, and if we use that, so this thing is, let's take this thing to be beta for the time being, and this thing square is 1, then c1 plus 1 by 1 plus so we have c1 mod square here. So c1 is basically e to the power I phi. The most general expression for c1 is this thing. Yes. Similarly, c2 is given by c1 times this, c1 times minus epsilon plus minus beta plus minus beta plus minus beta divided by 2 delta, and we know c1 as a function of all the known quantities, and so we know both c1 and c2.